Hello everyone, this is Dr. Indradeep Kumar, Assistant Professor, IARE, Hyderabad. So in this, our video topic is derivation of torsion of an arbitrary section beam. Right, in previous video also we had seen some part of the derivation that I already told you. With this we can derive the various derivations. So we will see the next derivation. Okay, this is the derivation. Now just see here. The question is, what derive the equation T equals to gz d theta by dz minus e tau r dq theta by dz cube. So now just see the difference. In the previous what we had seen, that just asked to derive the torsion equation, but now instead of asking, what they are mentioning, that T equals to gz d theta by dz minus e tau. So they given the final answer here itself. Now it's easier to derive. Once we have to read this, we have to reach to this one. But earlier what was there? That was not given. We have to derive all the value like tau r q r, that q tau tau tau, and then finally substitute here to get this one. So now this becomes easier. So let's see how they can change the question or twist the question. Either they will give you directly this one, or then they can give you this as, okay, derive the what Wagner torsion equation, or just derive the torsion equation for open section beam. So don't get confused if they are asking for the torsion. The same way you can go up to the what they are asking. Okay. So for a thin wall beam of arbitrary section, the student need to aware of the term stated in the equation. Means what is g, what is j, what is d theta by dz, e tau, r. These things you should know. That's why that is mentioned. Okay. So this question I have taken from the question bank. Your question bank is there. Even that you see this question is there. That's why I mentioned here. Why? Because already we had seen that derivation. That derivation was similar to the same to this one. So in exam, how they can ask instead of what we had seen derivation in that having the question of different way. But in exam, how they are asking, that is a different way. But the derivation will be same. All the procedure will be same. Only that they didn't mention in the derivation. That's just a final answer is there. Here they just given the final answer to derive that one. Okay. So let's start with the same. So in the presence of axial constraint, d theta by dz is no longer constant, so that the longitudinal strain del w by del z is what? Not zero, and direct and shear stress will be there. Hence direct and shear stress will what happen? Will get induced. Then sigma tau equals to e del tau by del z is equals to what? After substituting from the previous equation that you know what we are added. Right, what was that? In previous derivation we had seen w equals to what? Minus 2ar, okay, and d theta by dz. That was the, that was the wrapping. Just put here. So now just differentiate this one again, right? Because del w by del z is required. So del w by del z is equals to what? After differentiating this minus 2ar, this becomes d2 theta by dz square, and into that e here. So after substituting this value, so our dw by dz is this one. Just here multiplied by e. So after multiplying e, we got this equation, right? So it's not like for this question, right? This also, that also simply you can directly use this w value, because that you have to. So where this is there, so directly you can use the w value here. W we know from the wrapping that w equals to minus 2a r d theta by dz, and then differentiate and then substitute here. Okay, then sigma tau stress system must be self-equilibrating since the applied load is a pure torque. Why? Pure torque is there, means no other load is acting, means they should becomes equilibrium by their own. Therefore, at any section the resultant in a load is zero. So total overall resultant load whatever will act at any section must be equals to zero. So means what? Just whatever the total load is acting. Total load means integral is required. So integral of the total load is equals to 0. Where what? Sigma, that is the integral of C denotes integration around the beam section. Okay, or from equation first, that is here what observing d2 theta by dj square is a function of z. Hence that we can say that integral C of 2ar TDS equals to 0. Okay. The limit of integration of equation 2 presents some difficulties that already we are seeing, because in that figure also, here also I will show you in the figure same, right? That is difficult is 0 when W is 0 at the known value of S. If S is there, this S is acting, out some force is acting, that time what happened? AR is 0 when wrapping is 0. But force is there, then what about that force? What is the effect of that force? So that's why taking limit is here somewhat also difficult. Now for that only we have to find in terms of that one. Okay, so as I mentioned earlier also, this total is what your, here just see S is 0 here and up to this S is there, and that case wrapping is 0. When S is 0, wrapping is 0. That in previous slide itself we had seen, right? And just here where AR not is the area swept out from S equals to 0, right? So from S equals to 0, this part is your AS, that AR, right? AR, that, okay? So from here to here, this is the total AR naught. Why? That wrapping is 0 for this case. So this total is AR naught, right? And this is what? AR dash. This is 2 AR dash here, right? So just in all we are applying 2, so 2. So what will be this part? This part will be the whole minus this one. Whole is our AR naught, and this is what? This is A dash R, right? So this part will be what? AR naught minus A dash R. So here just see AR, that is 2 AR, because we require 2 in that equation, so just multiplied by 2. Don't get confused with 2 by 2 is there, right? In our formula 2 AR is there, so for that 2 AR, like for this, directly we can replace the value. That is equals to 2 AR comma 0 minus 2 A dash R. Okay, that we got. Now substitute this in where? Here. After getting the value of what? AR, the 2 AR value, substitute here. Sorry. So after substituting, what we will get? We got this one, right? First term and second term. So this one and this one. Okay. And now what we will do next term? Take this term to this side. So now what we have? Integral C 2AR comma 0 TDS equals to 2A dash R integral of C TDS. Okay. So now what we require? You have to find 2AR dash. So just keep 2AR dash one side, means this term. Right. So now after coming this term will be here, that got divided. So divided by integral C of TDS, just here. So this is the value of 2AR dash. Now substitute back this equation here, this value, to find 2AR value. So now what will be 2AR? 2AR will be equals to 2AR comma naught minus 2AR dash value. What is 2AR dash value? This one. So integral of C 2AR comma 0 TDS by C integral C TDS, right? So that is here 2AR value. Okay, so that is the third. Now we have AR dash value, AR value, and that in R naught is already, it's a given for the S. Now this one, the axial constraint shear flow system Q is in equilibrium with the self-equilibrating direct stress system, that already we know. So from equation 2, that del Q tau by del S plus T del sigma tau by del Z equals to 0. Hence, just take this term to this side. Okay, then what happened? Del Q tau by del S equals to del Q tau by del S minus T del sigma tau by del Z. Now we found that sigma T value. Just put that value and differentiate once again. So what we have, the sigma value, so just see here. Here, this is our sigma value, right? That sigma tau value. So this if you will put here, and this you will differentiate. After differentiating, what you will get? Minus 2ARE is constant. That is not. Then this becomes dq theta by dz square. So after differentiating this one, so that is used here. Right, after substituting from sigma tau, from that, substituting for sigma tau from equation 1 and noting that q tau is 0 when S is 0. We have what? That q tau is equals to, that q tau by ds should be here, but what? After taking this side, ds will be get multiplied here, and this ds is not here. So finally q tau is 0 to S 2AR ET dq theta by dzq into ds. So now with respect to s we have to integrate. So this term also will be what? Constant. Right? Already we are seeing that theta by dz is constant. Why? Because that integral is that variable is here s. So this e and 2ar will be what? 2ar, that ar won't be constant. Ar area is there, that depends on s. So e is constant, dq theta by dz is constant. So that is out of the integration, right? And 0 to s, 2ar t ds. Now put the value of ar and integrate, you will get the value of qt. This is for q tau. So now instead of integrating, just we require this q tau, so we found. Why? Because in t tau that is required, in Wagner torque that is required, right? So just see why t tau is equals to integral of c pr q tau ds. So now for this one q tau that is required. So what we will do? We will replace this value here for q tau. So after replacing the q tau value, what happens? Just substitute here, or simply you can say the pr, I'm just writing, so here p equals to integral of c pr into this value. So e dq theta by dzq, okay, integral of 0 to s, that all are in product, right? 2ar t ds. So this is the value of which one? Q tau pr, and this whole into ds. So after substituting here, that this value here, we got this one. Okay, that is the t tau. Now just integrate, because just see this is in the product form, so we can just integrate it. Yeah, substituting 4 in 5, what we got? That this is constant, so again out of integration, integral of c pr, close that one, 0 to s, 2ar t ds into ds, right? Simply just from this equation what we have taken. From this equation, e dq theta by dzq taken out, remaining everything is there. Okay, the integral in this equation is evaluated by substituting what? Earlier also we had seen that pr is as d 2ar by ds. So just replace p what? Pr as, so this pr as d by ds of 2r into integral of 0 to s 2ar t ds. So now just see here, ar also is there, here ar t ds is there. So now these are in the product form, right? So product form is what we have to do? Just for integration we are applying the integrating by parts, that means integration by parts. So just use that concept and integrating by parts. Thus after integrating this, what we will get? 2ar, that because this again integral of integral is there. So first we are integrating this integral only, right? Then next we will integrate this one. So after integrating this one, what we got? Yeah, let's see, close integral and this limit c, okay, minus integral of the second term of that one, minus 4a square r t ds. So this is that. Next, to find this overall value, this again is required. First substitute the value of c here, right? And then again integrate this part with respect to 0 to, that is with respect to s, right? So then put the limit 0 to s. Okay, this one. At each open is the beam q tau, and therefore 0 to s to ar is 0, right? So that integral. So now 2ar t ds, this is 0. So 0 into this, again this will be 0, right? So minus 4 integral c 4a square r t ds is there, right? So now this whole term will be 0, means what is left? Only this term. So just see, at each open is the beam q tau, and therefore 0 to s integral of 2ar t ds is 0, so that the integral reduces to this term only, right? That is minus c 4a square r t ds, giving what? Just here, okay? So e dq theta by dzq tau r, right? From here, so simply tau r is this one. So finally we have that tau of t tau is equals to minus e tau r dq theta by dzq. Not yet completed, still that, because in question itself, what is there? The here, this whole thing we have to prove. So this part only we proved, right? Now this part is left, right? Okay, so where Tau r is what? 0 to c 4a square r t ds. The torsion, so this term is called what? Torsion bending constant, and is purely a function of what? The geometry of cross sections. How the geometry is there, that's why we are not changing this value, right? We have taken always inside the integral, so that it depends on the cross section of the beam. Whatever the cross section, if it's circular, then that AR will be different. If it's rectangular, AR will be different. Triangular, AR will be different. So it totally depends on what? The cross section. But once that have the cross section, after that, that remains uniform. It's not like that, like cross section is here, right? And here this is more thicker circular type, and here it's a thinner. No, throughout it should be same. Whatever the shape is there, in that case only that depends, but this should be constant or same. The total torque T, which is the sum of what? Saint Venant torque and Wagner torsion bending torque, right? So what we found, that is here, this you can say what? Wagner bending torsion, okay? Wagner torsion bending torque, and that Saint Venant torque is here, Gj by Gj into d theta by dz. The total sum is there, so just add both the torque. You will get T equals to Gj d theta by dz minus E tau r dq theta by dz q, right? So up to this. So final answer now we reached here. So see, in previous video also we had seen the similar ways there, but depending upon what they are asking in the question. If suppose they ask in the question up to this itself, right? That Wagner torsion constant, that torque, right? That then you have to derive up to this itself. If suppose they are not mentioning in the question and they are just giving the question like derive the formula for what? Wagner torsion bending torque. So if they will ask Wagner torsion bending torque, then you have to just derive this term. This term is what? Up to here. So this is Wagner bending torsion torque, or Wagner torsion bending torque. Up to this you have to derive. If suppose they will ask the total torque, then you have to derive this one. If suppose they will directly give this one, then you have to derive to this one. So make sure do not confuse with the question what is given. First read the word properly, how the question is there and what is actually it's required, and derive up to that one. Okay. So let me recall again just quickly. So here what we did in question itself, it's a given that this we have to derive. Okay. So for that, again in the same previous way, we use that sigma tau is equals to E del W by del Z. So W is what? From that previous video I mentioned from where we got the W. So the W was minus 2AR d theta by dz. Just use that one. Right. So differentiate, because we require del W by del Z. So differentiate this equation. After differentiating, I'm substituting here. This we got. Okay. So now what is given? Only the pure torque is applied. There is no other loads are there. It's a self-equilibrating. It's coming self-equilibrium to the equilibrium position. This the total forces acting on the beam is 0. So total forces acting on the beam is equals to 0. Right? And then here what is observing d2 theta by dz square is function of z. It depends on z only. Hence 2AR TDS that is equals to 0. Right. Now what we will do, we have to find this AR. After finding this AR, we can substitute here and then we will integrate. So just see how to find AR here from this figure. This figure again we will see in find the twist, rate of twist. Right. So this figure is very important, right? To find the rate of twist. Why? Because to find this value, right, this figure is required. So wherever this type of derivation is there, this figure is must. That's why I added this figure here also to show how to find that 2AR values. Okay, so now finding AR means what? For S equals to 0, wrapping also will be 0. That time what will be the area from here to till here? This total area. Alright. Right? So from here to this total area will be your 2AR naught. Right? When wrapping is 0. That's why naught stands for when wrapping is 0. Now AR dash, for that this is from here to here is AR dash. Okay, so remaining is what? Remaining is only your AR. So can we write that this whole minus this part is your AR. So right, AR is AR comma 0 minus AR dash. Now just multiply because in formula 2 is there. So 2AR equals to 2AR comma naught or R naught minus 2AR dash. Now once we have 2AR, substitute in the previous equation, in this equation. After substituting in this equation, what we will get? This one. Right. Now just that equals to 0, take this term to this side. Okay, after taking this term to this side, what happened? This term is equals to this term. Now here we have to find AR. Right. So take AR, this will get divided here. So 2AR dash equals to this one. Right. Now substitute this 2AR dash back here. So now 2AR equals to 2AR comma 0 minus this whole term. So let's see here, 2AR equals to 2AR comma 0 minus this whole term. So now we have 2AR value. Now from the same again, this one, del Q tau by del S is the plus T del sigma tau by del Z equals to 0 for equilibrium. Now what happened? Just take this to this side. So that becomes the minus. Now just now we found that sigma tau, substitute here and then differentiate that one. Substituting sigma tau from equation 1 and noting that Q tau is 0 when S is 0. So after substituting, what we will get, and then just take this, multiply this del S here, or you can simply write del Q tau is equals to minus T sigma tau by del Z. Okay, here also del will be there into del S. Integrating both sides, integrating. So del Q tau is equals to integral of minus T, okay, then del sigma tau by del Z into del S, right? Integration of this will be what? Q tau equals to minus T del sigma Z we found from the equation, in that value you have to substitute here by del Z. So after substituting, differentiate, and then after differentiating, whatever you will get, that multiplied by ds that you have to integrate, and that is here, right? So that's here, that ds thing here. So Q tau is 2AR et dq theta by dz after differentiating once again. Now this you have to integrate from where? 0 to s. So here e dq theta by dzq is constant. That will be out of integral. So Q tau is e dq theta by dzq 0 to s 2AR t ds. Now t tau is what? PR into Q tau ds. Now substitute this Q tau here. So PR into this whole thing. Again, this is constant, that will be out of integral. Okay, that is here. Right. So this is constant, that is out of integral. C PR 0 to s 2AR t ds into ds. Now the integral in this equation is evaluated by substituting what? This PR value. What is PR? d by ds of 2AR, that is here. So this term into this term, that is product rule. Product rule for integral is by parts. Apply by parts. After integrating, we will get this one. But what is next? At each open edge, because we are deriving for open section, right? So at each open edge of the beam Q tau is 0, right? So this AR, that will be equal to 0, right? So once this is 0, then that is here, that 2AR t dash 0. So this term is 0, this into 0, whole term 0, only this term is left, that is here, reduced to this one. That gives what? T tau equals to minus E tau R dq by dz. Now next, the total torque. Total torque will be equals to what? That is the sum of which one? That St. Venant and Wagner torsion bending torque. Just add both. So this is St. Wagner torsion bending torque and this is St. Venant. After adding both, you will get the final equation what is required in the question. That is to derive this only was the derivation. Okay. So you can just refer the Maxim book. Okay. There you will get, and that again that mentioned that 21.8.1 for W, that what we used here. But in previous derivation I showed you the value of W, but here directly I used. So simply for that W you can use. And if you have any doubt, you can just contact me or just comment down the video itself. I will clarify that doubt. Okay. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.